how does a computer work? Well, let's look at the basic parts of the computer. As you probably know, are the CPU, or the central processing unit, and the RAM, or the random access memory. And let's start with the RAM. So the RAM is basically a big table that has all these buckets, and they're numbered, of course. So you start with 0, 1, 2, 3, 4, and so on, um, all the way down to how much RAM you have. So, for example, this machine right here has 4 gigabytes of RAM. Um, so that means that the last position here is somewhere around the neighborhood of 4 billion. Um, and it'll have some value there. So, and these are the indices, and then inside each one of these buckets is a number, or a byte. And as you probably know, a byte is equal to 8 bits. So which means that we can have a number between 0 and 255 in there. So, for example, at location 0 here, we might have the number 11. At location 1, we might have the number 65. At location 2, 212, and so forth. Okay, so what does the CPU do with the RAM? Well, basically, the only thing that the CPU can do is it can read information from the RAM, and it can store information back into the RAM at various positions. That is the only thing that it can do. So how does it do that? Well, each CPU that you buy, right? So the CPU, right now you could probably get an Intel or an AMD CPU, and each CPU comes with an instruction set. An instruction set. This is, if you will, it's the programming language that is hardwired into the CPU. So you can get, when you get a CPU, if you can search the internet, you can find the manual for your CPU, and you can get the instruction set, a list of all the instructions that the CPU implements. So, for example, one such instruction might be LDA, and then the load accumulator instruction. Inside the CPU, there is this accumulator, and also there is a program counter, and usually also some registers. This depends on the architectures. So, but roughly, the program counter is, all of these are just memory locations, or they work just like memory locations, but instead of being in the RAM, they are in the CPU, right? And the program counter holds a number, which is the number of the line that the CPU is running right now. So if it has number 4, that means that right now, the next thing that the CPU is going to do is going to fetch an instruction from location 4 in the RAM. So let's say that location 4 has the value 42, and the instruction set for this CPU tells us that 42 is the load accumulator instruction, which will mean that then, so the CPU reads the 42, realizes, oh, that means that I'm going to load whatever value is in the next box, the next memory location, in this case 5. I'm going to put that number into the accumulator. So I'm going to put the number 111 into the accumulator. And that's basically, so that's one instruction. Here I'll show you. It's a listing from the Wikipedia of an assembly language program, and you can see here it says the load accumulator instruction right there, and in this case the load is actually number 86, and the value that is going to load is 13, and that's going to do something with the CPU. Then the next instruction is store accumulator at this location. So B7 is the store key code, and this is the memory location where the value that was loaded into the accumulator 13 will be stored. There's also the jump instruction. Jump tells the program counter to jump to this other location. So it says, okay, you are memory location Z00D, go to the other location. So this is assembly language, right? So this, we would call this assembly language. These we'll call these bytecodes or machine language. It's a very simple translation from here to here, right? We just change the LDA to the number 86, and we changed this string to the number 13 because it was defined above here somewhere else to be the number 13. So that's how the program runs. That's all your computer can do. So your computer the CPU reads these instructions from the RAM. Those instructions tell it to do things to the RAM, and then it puts information back in the RAM. Now, you might be wondering, well, so how does, my screen work, right? So you have a monitor here, and you can see pretty pictures. You're looking at them right now. How does that work? Well, at its simplest, basically, if you look closely, you see that your monitor is just a bunch of pixels, one after the other, right? It has probably a resolution of 1024 by 768. That means that there's 124 pixels in the x-axis and 768 pixels this way. And what the way the computer is set up is that this first pixel here corresponds to a place in memory, right? And actually probably a set of places, the first 4 spots. And then the next pixel corresponds to another set of spots. And the value in these locations, if they're all 0, 0, 0, then that's going to be black. That means that pixel there is black. And if they're all 1, 1, 1, or 255, 255, that's usually white. And then the colors are somewhere in between. And that's how you see graphics. So the graphics that you see in the monitor are just taking the values from the memory and displaying them into the monitor, and that's what the hardware in your computer does. The other thing you might be wondering about is your hard drive, right? So this is your RAM. You typically have about 4 gigs of RAM. A hard drive, like the hard drive I have here, has 128 gigabytes of RAM. So why do we need a hard drive if we have the memory? Well, the main reason is the RAM is volatile. So when you turn the computer off, all these values, they go to 0. If you lose power to your computer, which happens when you turn it off, they'll go to 0, so you lose everything. You don't want to do that. You store it in the hard drive, or nowadays in your SSD drive, maybe. And these are non-volatile, so that means you turn the computer off and they're still there. And what happens when you turn the computer back on? The first thing it does is it looks for the values and puts them back into the memory.